Assalamualaikum. How are you, Shavi?
I'm good. I'm good.
Okay. Is my voice is clear?
Yeah,
Okay, so let's start our today's lecture number 10. Are you ready for
yeah,
that?
yeah.
Have you prepared your previous lectures?
Um, don't think so. Well, the other ones for moving house show, I think I've packed them away.
Okay,
Some of the homework things I've done.
sure. So let me share my screen for today's lecture. So my screen is sharing with you.
Yeah.
Okay. So here's our lecture number 10 today. Today's lecture is very easy and quite familiar with we did in our previous lectures. In today's lecture, basically, we are going to discuss about free fall, okay, free fall motions, and we can say vertical motions, okay. You know somehow about what are free fall motions. Can you tell me what are free fall
hmm
motions? What
Um,
does this free fall means? Body
what,
moving under the action of,
gravity.
yes, gravity. So this we will discuss in today's lecture, how bodies behave when they will move under the action of gravity, or how if they can move against the action of gravity. Because you know that the gravity always pushes objects downward, okay, and if an objects move against the action of gravity, then they move
hmm
forward. So upward and downward motion are so called as the vertical motions, right? So that's why these types of motions, free fall motions, are also called as the vertical motions. All right. So here are our learning objectives. We will
hmm
understand the concept of free fall, okay, how bodies behave when they move under the action of gravity or against the action of gravity. Then we will discuss, apply those three equations of motions which we discussed in our previous lectures. You know how many equations of motions are there in total?
Um, three.
Um, yes, three equations of motion. Uh, any equation of motion you remember? First, second, or third?
Um,
Okay.
Not really.
Okay, so we will again do those three equations in today's lecture. Okay, so then we will analyze upward and downward motion when how bodies behave when they will move upward. Upward means they are moving against the action of gravity, and downward motion means the bodies are moving under the action of gravity. Okay, and then we have some practical solved problems related to these free fall motions. So let's start. What is free fall? We have to know how about what is free fall. Basically, free fall is a motion of an object under the influence of gravity only. Okay, when gravity acts on objects, then those objects behave to be moved under the action of gravity, and those types of motion are called as the free fall motions. Okay,
hmm
if bodies influenced motion with some other sort of things, those motions are not called as the free fall motions. Okay, the only objects that move under the influence of gravity, those objects are called as the they obey free fall. Okay, but in this free fall scenario, you must have to ignore the air resistance. Okay, this is the important thing which you must have to understood that in free fall, you must have to ignore the air resistance. All right.
hmm
Why you are ignoring the air resistance? If there is no air, so the thing is so called as the vacuum. Am I right?
Yeah.
Yes. So if there is air, you know that according to Newton third law of motion, action and reaction, if your body is falling downward, those particles in the air also exert some force on that body. So your body is moving downward, and those particles of air also pushes you upward. So that's why we must have to ignore anything which is against. So that's why we are ignoring the air resistance, because air consists of particles, and particles have masses.
Mm.
Okay.
So does that cause
And
friction?
yes.
Does that cause friction? That when it falls and then it goes against the air?
Sorry, I'm not getting.
When an object falls, goes
Yes.
against the particles in the air, is that like
Mhm.
friction?
Yes, those body will have to interact with the particles of that air. So then we cannot easily find the motion of a body. If you want to find the exact motion of a body, you must have to ignore the air resistance or anything which is between, right?
Mm.
So
Yeah,
that's why we have to ignore everything. That's why we are ignoring air resistance here. And you also know that what is the value of our gravitational field of the Earth, which is
9.8
9.8. And
meters
you
per
know,
second.
meters per
Meters
second
per second.
square, right? So here is some acceleration due to gravity, which you know is denoted by this small g, and its value is standard value is 9.8. But sometimes for our easy calculation, we can use 10 meter per second square. And gravity always acts downward, as I mentioned you before. And if your body is moving upward, it means they are moving against the action of gravity. So it means you have to take the value of acceleration minus g. Do you know? We already did this in our previous lectures in example problems.
Mm-hmm.
And if a body is moving downward, it means they are moving under the action of gravity. And if a body is moving in the action of gravity, then you have to take the acceleration of that gravity is positive g, means positive acceleration. Here are basically our three equations of motions. Now you remember?
Yeah.
Yes, this is our first equation of motion, and these three equations of motion can be used in every case. You can use these equation of motions for vertical motions as well as for horizontal motions. In previous lecture, we solved these equation of motions for horizontal motion, right? But in today's
Mm-hmm.
lecture, we are going to use these three equations of motion for the vertical motion, because our gravity is a vertical motion, okay? And these equation of motions are also called as the kinematic equations. Kinematic means, I
Um,
told you before, kinematic means your body is moving, your body is in motion, okay? Kinematic basically means your body is in,
motion.
yes, motion. So everything, everywhere, if your body is in motion, either vertically, either horizontally, you have to use these three equations of motion. This is your first equation motion. As I mentioned you before, this V stands for the final velocity, and this U stands for the,
Initial.
yes, U stands for the initial velocity. Whereas A is the acceleration of the body, and T is the time taken by the body. So
Mm.
again, this is our second equation of motion. In this, you can see this S. This S basically represents what?
Uh, speed.
Yes, speed. This S basically represents the speed, but you can here you can represent S by the distance covered by the body. Here S represents the distance, the total distance covered by the body. Okay.
Mm-hmm.
Okay, and again, U is the Initial velocity time is t is the time taken by the body, half at square. This is your second
Mhm.
equation of motion. And this is your third equation of motion, whereas your final velocity square equals to initial velocity square plus 2as. So again, in today's lecture, we are going to use these three equations of motions to solve our vertical motions, or you can say that the free fall motions. Understood?
Mhm. Yeah.
Wonderful. Here are some tips that if your motion is upward, so velocity always decreases. Uh, you know that whenever you fall something upward, that
Mhm.
body achieves a maximum height. But when they achieving some maximum height, their velocity remains decreasing simultaneously. Okay. So whenever you fall some objects upward, so their velocity decreases and their acceleration would be minus g or positive g.
Uh, minus G
Yes, minus g. Why minus g?
because it's decreasing
Yes,
or
it's yes, the
yeah.
velocity is decreasing, but why acceleration is minus g?
Uh, is it because it's going against the force of gravity?
Yes, because the object is moving against the force of gravity, right? And at the highest point, your final velocity would be
Zero.
yes, zero, because the body has to be stopped at the highest point, and again they have to fall against the under the action of gravity, right? So this is
Mhm.
for the upward motion. What if for the downward motion? Downward motion, your velocity would increase or decrease?
Increase.
Yes, increase. Because if you're you can if you fall something from height, you can see uh, time to time your body's velocity gaining increasing their velocity because they are moving under the action of gravity, and
Gravity.
in that scenario your acceleration would be positive or negative.
Positive.
Yes, acceleration would be positive because your body is moving under the action of gravity. So from rest or returning after upward motion. These tips are for the downward motion. Any question regarding this? Any question?
No.
Okay. So here are some key points which you have to remember. So what are those? Those key points are if your object dropped from rest. So you can take their initial velocity what?
Uh, Zero.
Yes, zero. Because as I mentioned you before, if your object is at rest, so their initial velocity must be zero. Okay.
Mm.
And at the maximum highest point, what would be zero? Initial velocity or final velocity?
Final velocity.
The final velocity would be zero. So you can say when your body is at rest, your initial velocity would be zero. And when your body is at your maximum point, then your final velocity would be zero. Is there any question?
Mhm.
Okay. So these are basically the sign conversions, which you already know. So now let's solve some work example problems. And these problems are from vertical motions. So a ball is dropped and hits the ground after 4 seconds. Find velocity just before impact. They haven't mentioned which velocity you have to find. How you know that which velocity we have to find? They are asking find velocity just before impact. It means you have to
We have
find
to find
final or
the
initial.
Final.
Yes, final. Because you have to find the velocity just before hitting the ground. So you have to find the final velocity. And here he says a ball is dropped and hits the ground. Definitely a ball is dropped from some highest point. Okay.
Mm.
And they haven't mentioned any initial velocity because they dropped the ball. Let's suppose the ball is either in their hand or something he spotted. So their initial velocity would be,
Zero.
yes, zero, because a ball is dropped. Okay, either is in hand or something, they are just picked up. So that's why their initial velocity would be zero. But first, before that, you have to tell me which equation of motion we have to use in this scenario. The initial velocity is given, we have to find the final velocity, and the time is given. So, which equation of motion is helpful to solve this problem?
Uh, is it the first one?
Yes, the first one. Because in first equation of motion, we know that you can see here the final velocity is also here, the initial is here, the time is here, and A we always know. A is basically the
Gravity.
gravitational acceleration, we can say. Okay.
Mm.
So yes, we can use the first equation of motion. In that scenario, we have to find the final velocity, which is v, and initial velocity, as I mentioned you, we have to take zero. The value of g, we take minus 9.8 or we take positive 9.8. Can you tell me in this scenario what?
Uh, Positive.
Yes, positive, because a ball is dropped from some height. And definitely the ball have to drop downward or upward, downward. And we know
Mm.
that downward motion we have to take positive 9.8. Okay. So that's why here we have to take a positive 9.8 multiplies by time. So just multiply 9.8 by 4, you will get your answer, which is 39.2. Because you are find final velocity, and we know what is the unit of velocity, which is meters per second.
Meters per second.
Yes. Is there any question?
Nah.
Okay, now move next. A stone is thrown upward at 20 meter per second. How high does it go? So basically, they are asking to find,
The Sounds like they're trying to find the distance.
yes, they are asking to find the distance because they are asking how high does it go. So height we can find basically by finding the distance. What things are given in the problem? A stone is thrown upward at 20 meters per second. So this is initial velocity or final velocity?
Uh,
Initial or final?
no,
A stone is thrown upward at 20 meters per second. So this 20 meters per second is the,
I'm not sure.
yes, initial velocity. Because you have to throw stone upward. The stone does not go upward by himself. You must have to provide some external force, right? If you are dropping something, do you need any external force to drop something?
Uh,
Sorry, I'm not getting a voice.
No.
Yes, no. And if you want to throw something upward, do you want some external force?
Yeah.
Yes. So in this scenario, a stone is thrown upward. So you must have to provide some external force. And in this scenario, this velocity behaves like an external source. So this is basically the initial velocity. So you must have to provide initial velocity to the stone, then the stone moves upward. So this 20 meters per second is the initial velocity. And you have to find distance. So can you tell me which equation of motion we have to use? In this problem, time is not mentioned. So you know in which equation of motion time is not given.
The
First,
third one.
second. Yes, the third one. So it's clear that you have to use the third equation of motion to solve this problem, which is v square equals to u square plus 2as. Again, can you tell me what is the final velocity in that case? The final velocity is not given, but we learned in this key points that we must have to take final velocity which is
Zero.
zero. If you throw something upward, you always have to take the final velocity which is zero.
Zero.
So again, you can see u square, sorry, v square, the final velocity I take 0 equals to u square. U is 20. 20 square becomes equals to 400, right?
Mhm.
Plus 2as, 2. Why I am taking a equals to minus 9.8, not positive 9.8?
Because it's going against the force of gravity.
Yes, because it is moving against the force of gravity. And the s as it is, because s is the thing which we have to find the distance. By just substitute your equation, you can easily find your distance, which is 20.41. And what is the unit of distance?
Meters.
Yes, meters. So your answer is 20.41 meters. Any question regarding this problem? Okay. Can we move next?
Yeah.
Okay. So in third problem, you have to find the time. Okay. A ball is thrown up. Now, by this statement, you again know that you must have to provide some external force, and this is the problem related to in which your body moves against the action of gravity because you have to throw a ball up with velocity of 15 meters per second. So this 15 meters per second is their initial or final?
Initial.
Yes, initial velocity. How long to return? Basically, they're asking you to find,
Time.
yes, the time. How long basically means you have to find the time. So the third equation of motion we cannot use because in third equation of motion there is no time. So the remaining are first or second. So can you tell me which equation of motion we have to use? First or second?
Second.
Uh, but in second equation of motion we require distance s.
Oh, first.
But but in this problem we the distance is not given. So we have to move on towards the first equation of motion.
Mhm.
So if we arrange our first equation of motion for time, how it looks. First of all, you have to move this u to the other side. So it becomes v minus u,
You.
v minus u. I am right.
Yeah.
Whenever you take something to other side of the equal sign, the sign changes. You know that.
Hmm.
So it becomes v minus u equals to at, but we only need time. The a is extra. So we have to divide a to the other side. So t becomes equal to v minus u divided by a. What we write here you can see. V minus u divided by a. Is it
Mm.
understood? Is it okay? Okay.
Yeah.
So in that problem again, can you tell me what the final velocity we have to take? The final velocity is not given, but you know that we have to take the final velocity which is equals to,
Zero.
yes, 0. So final velocity 0 minus initial velocity which is 15 divided by acceleration. In that scenario, you have to take minus 9.8 or positive?
Uh, Minus.
Yes, minus 9.8 because the ball is thrown upward. Minus cancels with this minus. Just divide your 15 by 9.8. You will get your answer which is 1.53 seconds. This is the time taken to reach the highest point. But if they ask you to find the total time, what you have to do? The same times they require to drop down. Okay?
Oh,
If you throw a
to,
ball up,
to
they reaches the highest point in this time. But if they ask you to find the total time, means the time the ball again comes in your hand. So just multiply your
Divided by two.
answer by two, okay, twice. So 2 multiplied by 1.53, you will get your total time, which is 3.06 seconds. Any question?
Mm. No.
Okay. Our fourth example is, how far does an object fall in 5 seconds? So in this scenario, only time is given and they're asking you to find how far, means distance.
Distance.
Yes, distance. So distance are in second equation of motion and third equation of motion. So in this scenario, what we have to use? The
Second
time,
equation.
the time is given, and you know that the time is not mentioned in third equation
Third
of
equation.
motion. So that's why you are not using the third equation of motion. You're supposed to use the second equation of motion, which is s equals to ut plus 1 by 2 at square, or you can take the gt square, because
Mm.
a and g are both the same, both are accelerations. So you have to use this. Again, the how far does an object fall in 5 seconds? Now, if an object again fall, you have to take the initial velocity, which is equal to,
Uh, zero.
yes, 0. And 0 multiplied by time, which is 5 seconds. 0 multiplied by 5, it becomes 0.
Zero.
Plus 1 by 2, which is 0.5 gt square.
Mm-hmm.
Because your body is moving under the action of gravity, that's why you have to take 9 positive 9.8 multiply by t square. T is 5 and 5 square is 25.
Mm.
So just multiply, you will get your answer, which is 122.5 meters. This is how you can find the distance.
Mm.
Okay. Now
Yeah.
move over last problem, which is an object falls 80 meters. Again, your object falls. Basically, it means they are moving under the action of gravity. Find its final velocity. You have to find the final velocity. And this 80 meters is basically the distance given. So which equation of motion we are supposed to use in this scenario?
The first.
Yeah,
Third.
guess the third one. Because the time is not given in this problem. And the only equation in which time is not mentioned is the third equation of motions. That's why we are going to use the third equation of motion, which is final velocity square equals to the initial velocity square plus 2as. So you can take 2gs.
Mm-hmm.
Again, object is falling. You have to take the initial velocity, which is 0 plus
Yeah.
2gs, and your body is falling under the action of gravity. That's why you are taking positive 9.8 multiply by the distance, which is s, 80 meters. Just multiply to 9.8 and 80, you will get your answer, which is 1568 meters per second. But on the other hand side, you can say here is square,
Squared.
final velocity square, but they're asking you to find only final velocity. So what we have to do, if we have to remove the square,
Square root.
yes, we have to take the square root on the both sides. So square root taking on this side, square cancels with the square root. You will only left with v, which is the final velocity. And the other
Mm-hmm.
side, you can take the square root, and the square root of this is approximately equals to 39.6 meters per second, right?
Mm-hmm.
Okay. Any question regarding these examples?
No.
Okay. Now let's move on towards our quick quiz for you. You can answer me these questions. Definitely the answers is mentioned also. What is the value of G near the Earth's surface? Can you tell me?
9.8 meters per second squared.
All right. Can you tell me what is the velocity of an object at the top of its upward motion?
0.
Yes, and good. How long does it take to fall 20 meters from rest? So this is a problem basically. So can you tell me in this problem which equation of motion we are going to use?
Second.
Yes, the second one. And you know that second equation S equals to Vt plus 1 by 2 At square or Gt square. But where
Uh,
V goes,
uh,
S
where what
equals to
goes?
ut. Initial velocity is vanishes. Why? Because you know that we have to take the initial velocity 0. So when 0 multiplied by time, it vanishes and you will only left with 1 by 2 gt square.
Yeah.
This is your okay. This is your second equation of motion. In this scenario, u is 0. So
Mm-hmm.
u multiplies by time. So this whole is 0. So that's why we are
Yeah.
ignoring. So you are only have to write 1 by 2 gt square. So this is how I write here 1 by 2 gt square. And they're
Mm.
asking you to find what? How long?
The distance.
So how you can find?
Just
Can
using
you
the second.
substitute? Can you substitute this equation for time?
Uh, yeah.
How? Can you tell me first?
Move the T over with the S, or move the 1 by 2 with the S with the G,
Mm-hmm.
and then that will be like 2 squared equals S 1 over 2 G. Get the
Yes, this
answer,
is
and then
yes, you can like that. Simple is that you first of all you have to find t. What you have to do, you
mm,
have to move this 2 to the other side. So it becomes 2s on the other side.
mm,
So 2s equals to gt square. You have to find t. The g is extra. You have to divide g to the other side. So it becomes 2s divided by g equals to
G,
t square.
G
So here you can see 2s divided by g. Here is the t square. But we only need t. Again, you know that if you want to remove square, you have to take the square root.
squared.
So on this side, you have to take square root. Square cancels with the square root. And when you take square root to this side, so here you know already here is 2s divided by g. So here t equals to under the root 2s divided by g. So this is how you can substitute for t. The other things are mentioned 20, which is the distance. So 20 multiplied by 2, it becomes 40 divided by g, which is 9.8, because your body is moving under the action of gravity. And when you will calculate, you will get your answer, which is approximately equals to 2.02
2.02.
seconds. Okay. Can you tell me an object falls for 3 seconds? What is its velocity? Again, object falls for 3 seconds. In this scenario, your initial velocity would be
0.
0 because your body is falling from some height. Okay, you have to take the
Mm-hmm.
initial velocity 0. And which equation of motion we have to use in this scenario? The
The
time is
first
given,
one.
velocity is given. In third equation of motion, there is distance. But in this problem, we don't have any distance.
So we use the first one.
Yes, so we use the first one. The first one is the only equation of motion in which there is no distance, right? So you can see here is the first equation of motion, this. In that
Mm.
scenario, your initial velocity is 0. That's why I vanish this side. So again, V equals to GT. So here what I write, V equals to GT, because here I vanishes the initial velocity.
Mm-hmm.
Because your body is falling, that's why I have to use the positive 9.8,
9.8
and the
positive.
time, which is 3 seconds. So just multiply 3 by 9.8, you will get your answer, which is 29.4 meters per second. Okay.
Mm.
Okay. So these are some assessment questions. You can do practice of these questions, okay, at your home for your
Okay.
better explanation. Okay.
Good.
So just wrap up is basically free fall is a motion in which your bodies are moving under the action of gravity, or you can say the vertical motion. And the convention value of gravity, you know, that is 9.8. If your body is moving downward, you have to take 9.8, and if your body is moving upward, you can take minus 9.8, because that body is moving against the action of force of gravity. And those three equation of motions you can practice by using in these assessment questions. So there are
Mm.
some facts for you. The first fact is that all objects fall at the same rate in vacuum. Do you know why?
Uh, is it
All
because there's no
objects,
air resistance?
yes, because there is no air resistance. As I mentioned you before, if there is no air resistance, means if there is no particle, so every object fall at the same rate. They reaches the ground at the same time. Let's suppose if you fall a feather and a hammer in a vacuum, or you can say on a moon, because on moon there is
Like zero
no,
gravity.
yes, there is zero gravity. There is no resistance. There is no air. Okay, on moon there is no air resistance. So that's why if you drop a feather or a hammer on the surface of a moon, so you can see your feather and hammer reaches the ground at the same time. This thing is
Mm-hmm.
demonstrated by an astronaut, David Scott, okay, in Apollo mission 15. Okay.
Yeah.
And the second fact is that if you drop a ball from the top of the Eiffel Tower, and the height of the Eiffel Tower is 300 meters, it will hit the ground in approximately 7.82 seconds if you ignore the air resistance. So this problem is solved by using first equation of motion. Okay,
Mm.
because we know what is the height of the Eiffel Tower, which is 300, which is 300 meters, and we know what is our initial velocity. And whenever our ball drops, we can easily calculate how much time it takes from the top of the Eiffel Tower to the bottom of the Eiffel Tower. But if we ignore the air resistance, but if we not ignore the air resistance, this answer should be high or low.
Uh, high.
Yes, high, because that ball have to resist more into that air. They have to resist those air particles. Okay,
Mm-hmm.
that's why we have to ignore air resistance. But if we are not ignoring air resistance, then our time, the body will take more time. So that's all for our today's lecture. Any question regarding today's lecture?
Nah.
Okay, so I can share PDF with you. The PDF is also attached with this meeting. You can download. Okay, I can also share with you.
Okay.
You can revise those lecture.
All
So
right. Thanks.
till then, take care. Allah
All right,
Hafiz.
you too. Allah Hafiz. Bye.
Thank you.